Hello everyone, let us talk about cubic polynomials. We have an example here. F of x is equal to x cubed minus 6x squared plus 11x minus 6. If we need to find its roots, we put it equal to 0. Upon factorization, what we get is this. X minus 1 times x minus 2 times x minus 3 equal to 0. That means x can be either of these, 1 or 2 or 3. These are the roots. And in a standard form, we also call these roots as alpha, beta, and gamma. But did you notice one thing? If we multiply these roots, 3 into 2, 6 into 1, which is 6, I get this constant term. So, is there some kind of relation between the roots and the coefficients? And is there a relation between the roots and all of these coefficients? The coefficient of x cube, x square, x, and constant. That is what we're going to see now. In order to find that, let's do one thing. Let us write the standard form of a cubic polynomial, which will be ax cubed plus bx squared plus cx plus d. A is the coefficient of x cubed term, b is the coefficient of x squared term, and so on. Now, once again, we put it equal to 0 to find its roots. And the standard roots are x minus alpha, x minus beta, x minus gamma equal to 0, right? Now, think about this. If I get this upon factorization, once I multiply this, I get this polynomial back. Same goes for this one. So I'll get this back if I multiply these three factors. Now, for the standard form, we'll also multiply a constant factor k over here. Now you might be thinking, why do we do that? Okay, let us look over here. Let's put it to one side for now. To factorize, we put it equal to 0. This entire term is equal to 0. That means this entire term is equal to 0. Now, no matter what value of k I put here, 1, 2, 3, it's going to be 0. So, the roots are not going to change. Roots are going to stay the same. Then why do we put a k? K is basically a scaling factor which makes a graph longer, steeper, or shorter. Let us see this through one example. If we have certain values for alpha, beta, and gamma, and let us put k equal to 1. In that case, a polynomial f of x becomes this. Substitute the values and we get this polynomial. If we try to plot this on graph, we get this graph. Now look over here. The polynomial is cutting the x-axis at the said roots, -2, 1, and 3. And the graph looks like this. Now once I put k equal to 2, my polynomial becomes this. Now if you plot this on a graph, the graph looks like this. Once again, we have the roots at the same place. The roots are the same, right? It's -2, 1, and 3. But this graph looks a bit stretched. It looks longer than this one. So for different values of k, we have different looking polynomials and different looking graphs. Now, since we need a generalized form, so we do not have any specific value for k, we put a constant k over here which can take any value. Alright. Now let us do this multiplication. If we multiply these two terms, we'll get x squared minus alpha x minus beta x plus alpha beta and this term. Now I need to multiply x with the entire term and negative gamma with the entire term. So this is how it will look like. Let us multiply k. This is x cubed minus alpha x squared minus beta x squared plus alpha beta x minus gamma x squared plus alpha gamma x plus beta gamma x minus alpha beta gamma. Now, let's again write k x cubed. Let us collect the x squared terms, which is negative alpha, negative beta, negative gamma. Okay, let's take negative x squared as common. Then we are left with alpha plus beta plus gamma. Similarly, let us collect the x terms. We have alpha beta plus alpha gamma plus beta gamma. Lastly, we have negative alpha beta gamma. Now, let's multiply k with the entire term. So we get this. Okay, let's do one thing. Let us rewrite this on a cleaner page. Now, if you compare the left hand side to the right hand side, compare all the terms. If we compare x cubed terms, we get a equal to k. And if we compare the x squared terms, we get b equal to negative k into alpha plus beta plus gamma. That means alpha plus beta plus gamma is equal to minus b by k. And k is nothing but a, right? It's equal to a. So this becomes minus b by a. That means the sum of roots of a cubic polynomial is equal to b is what? B is the coefficient of x square and a is the coefficient of x cube. So sum of roots is equal to minus coefficient of x square upon coefficient of x cube. And that is a good relation. Now let us compare the x term. So we get c equal to k into alpha beta plus beta gamma plus alpha gamma. Once again, alpha beta plus beta gamma plus alpha gamma is equal to c by k or c by a. Now c is the coefficient of x and a is the coefficient of x cube. So we get this relation, and this is called sum of product of roots equal to coefficient of x upon coefficient of x cube. Lastly, let's compare the constant terms. D is equal to minus k alpha beta gamma. Alpha beta gamma is equal to minus d by k or minus d by a, which is minus constant upon coefficient of x cube. These three are the most important relationships between the roots and the coefficients of a cubic polynomial. Let us summarize this once. So the relationship between zeros and coefficients of a cubic polynomial are sum of roots equal to minus b by a, sum of product of roots equal to c by a, and product of roots equal to minus d by a. This is quite easy to memorize as well. We have a in the denominator, and for the numerators we have b, c, d, and alternate signs, negative, positive, negative. Now let us proceed to one question. Verify the relationship between zeros and coefficients of this cubic polynomial whose zeros are 2, minus 2, and minus 3. So alpha is 2, beta is minus 2, and gamma is minus 3. Let us start the verification. We have sum of roots equal to minus b by a. So let's substitute the values. B is coefficient of x square, which is 3. So minus 3 by 1. A is 1 over here. These two cancel out. It leaves us with minus 3 equal to minus 3. Verified. Let's do the next one. Alpha beta plus beta gamma plus alpha gamma is equal to c by a. C is the coefficient of x. Let's put the values. So c is negative 4, a is 1. So this becomes minus 4 plus 6 minus 6. These two cancel out. We get minus 4 equal to minus 4. Lastly, we have product of roots, which is minus d by e. So let's put the values. D is negative 12. So negative of negative 12, this becomes positive, right? And this is 3 into 6 into 12. Positive 12 equal to positive 12. Hence verified.